MSQ question number 40. In this question, an NPN transistor case is given. In this transistor, we have been given that 95% of the emitted electrons reaches the collector. Now, the collector current is 19 milliampere that is given to us, and we have been asked to calculate which of the following statements are true. First of all, we have been clearly told that 95% of the emitted electrons reaches the collector. So we know the value of alpha, that is IC by IE, which will be equal to 95% or 0.95. If we know the value of beta, we can further move on to the next parameters in this question. Now to calculate beta, we can use alpha because beta equals to alpha upon 1 minus alpha. If we use this expression, we will get beta equals to 19. Now, IC is given to us, that is 19 milliampere, and beta is being calculated to 19. So we can calculate the value of the base current, that is IP, which is equal to IC by beta. And the value that we will get is 1 milliampere. If we know the value of IB, then we can also calculate the value of IC, which will be beta times IB, and it will be the same as the given quantity. So the correct option in this question will be option A, B, C and D. NAT question number 41. In this question, we have been given that the power radiated by sun is 7.6 into 10 raised to the power 26 watts. And its radius is 7 into 10 raised to the power 5 kilometers. Now we have been asked to calculate the magnitude of the pointing vector in watts per centimeter square at the surface of the sun. Now the magnitude of the pointing vector can be calculated by a definition of the pointing vector, that is, the pointing vector is equal to the power radiated per unit surface area. Now the power radiated by the sun is given to us, that is 7.6 into 10 raised to the power 26, and the surface area of the sun will be 4 pi r square. So the area or the surface area of the sun can be written as 4 into pi into r square. In watts per centimeter, we can easily calculate our answer, and that will be equal to 12349 watts per centimeter square. So our correct answer will be 12,349.
NAT question number 52. In this question, the total power emitted by a spherical black body of radius r at temperature capital T is P1, and P2 be the total power emitted by another spherical black body of radius 2r at temperature T by 2. In this question, we have to find out the ratio of power emitted by the first spherical black body to second spherical black body. So by the Stephen energy law, we know that for the black body, total energy per unit area per unit time equals to sigma T to the power 4, where A is area, T is time and E is energy. And power is defined energy per unit time. That implies P1 divided by P2 is equals to sigma T1 to the power 4 A1 divided by sigma T to the power 4 A2. That is equals to sigma T1 to the power 4 divided by sigma T to the power 4 into 4 pi R1 square divided by 4 pi R2 square, where R1 is the radius of the spherical body of first one and R2 is the radius of the spherical body of second one. So P1 divided by P2 is equals to T divided by T by 2 whole power 4 into R divided by 2R whole power 2. That implies P1 divided by P2 is equals to 4. NAT question number 58. In this question, we have to find out the minimum energy of a collection of 6 non-interacting electrons of spin -12 and mass small m placed in one-dimensional infinite square well potential of width L in the unit of pi square h cut square divided by ml square. So first of all, we know that for one dimensional square potential box, energy eigenvalue is given as En equals to n square h cut square pi square divided by 2ml square, where L is length of the box and n is allowed states. By using the Pauli exclusion principle, the total energy of the system is equals to 2E1 plus 2E2 plus 2E3, where E1 is ground state energy, E2 is first excited state energy, and E3 is second excited state energy. For ground state energy, n equals to 1, for first excited state n equals to 2, and for second excited state n equals to 3. So total energy of the system is 2 into pi square h cut square divided by 2ml square plus 2 into 4 pi square h cut square divided by 2ml square plus 2 into 9 pi square h cut square divided by 2ml square, that is equals to 14 pi square h cut square divided by ml square, that is equals to 14 pi square h cut square divided by ml square.